so far we have looked at sampling distributions in general. So the biggest things I want us to know before we get into these notes, I want you to be able to tell me what is a sampling distribution. I want you to be able to, like in the homework, look at some sampling distributions and tell me if those statistics are biased or unbiased. And then I think you should be able to list some of the biased or unbiased ones. Last thing that I forgot is, like that question 13 on the homework where it has the dot plot, you have to be able to determine, do we have convincing evidence, yes or no? So the last two things that we're going to do in this unit is we are going to focus on the two big unbiased estimators. Today we'll talk about proportion, and then way after break, we're going to talk about mean. So I want us to write down a few things. So first thing we know is we know that sample proportion is an unbiased estimator of population proportion. And just symbolically, population proportion is P, sample proportion is P hat. So we are going to focus on proportion, and then later we're going to focus on mean. The question we should be kind of thinking in our heads right now is why proportion and mean? Besides the fact that they're unbiased, why are we doing both of them? So what I want to recall for us is that proportion is used for categorical data. That's the reason we focus on proportion. If we have a variable that's categorical, the first thing that we're going to do is we're going to calculate some proportions with it. If we have data that's numeric, we're going to calculate the mean. Okay, so first thing that we're going to do is we're going to take a look at an applet. I'm going to play around with it for a little bit, and then you guys are going to play around with the person next to you, and it's this candy machine applet. Okay, before I let you loose to do that yourself, I want us to do this part A together, and then you're going to be doing this part down here. In the context of the candy machine applet, explain the difference between the population, the sample, and the sampling distribution. What are the individuals in each distribution? Okay, so we need to talk about what is the population, what is the sample, and then what about the sampling distribution? And then it asks us specifically, what are the individuals? So individual, every dot on the dot plot. What is the individual? Okay, so the population is all candy in the machine. Okay, the sample is the 25 candies chosen for our one specific sample. And then the sampling distribution is the sample proportion for all possible samples of size n equals 25. So then the big difference in these is who are the individuals? Well, in the population, we are looking at each piece of candy individually. So it would be like going through and saying, okay, this one's red, this one's yellow. That's the population. In the sample, again, same thing. I'm looking at each piece of candy individually. Sampling distribution is different, though. So if we think of the dot on the dot plot, it does not represent a specific piece of candy. Instead, it represents a sample proportion. So here the distribution represents each piece of candy, a group of candy. Okay, so here's what you're going to be doing. You are going to be playing around a little bit down here. You have 6 different ones that you are going to do. In each box, you are going to use the simulation. We're going to take 100 samples. So every time I want you to take 100 samples. Let's take 1,000. So maybe you want to write that down. So you're going to do 1,000 samples in each box. The first one, your samples are going to be 25 candies. The probability of orange is 0.1. Second box, samples of size 25 still. Probability of orange is 0.5. What you're going to be looking at is the shape, center, and spread. The shape, center, and spread. And there's a few things that I want you to notice. So sketch a little graph maybe for each one. Maybe you want to give the mean and the standard deviation if it gives it to you. And then we're going to be making some conclusions. So let's take a look at the applet again and let's see what information it'll give us. So if you want to look up here, in the interest of time, I just want to start talking and see what did we see. Okay, first let's talk about center. We should have seen that in this first graph the center was around 0.1, second graph the center was around 0.5, third graph the center was around 0.9. Okay, why is that? Matthew, thank you.
Proportions unbiased.
Okay, so the center is always going to be at P, and that is because sample proportion is unbiased. Even when we changed to n equals 100, the center was still 0.1, 0.5, 0.9, about. What about spread? What happened to the spread as P got bigger? Nothing happened? It was unchanged? Okay. What happened to the spread as n got bigger? So we went from n equals 25 to n equals 100. What happened to the spread? It decreased, right? And we already knew that that was going to happen. So the spread, as n increases, the spread decreases. The one that I was hoping we would notice is the shape. You should have ended up with a few distributions that were symmetric, maybe normal. My guess is that your graphs that were here, 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 and maybe here looked about normal. Is that true? This one up here on the left was skewed and this one was skewed? Okay. So then, what is in common with this bottom row that they would all be normal? Why is the bottom row normal and the top row is not? What's the difference? N is bigger, right? N is bigger is going to lead us to more normality. Okay, and then P we noticed, P low is not normal, P high is also not normal.
Sorry to disrupt your class. Would you or anyone in your class be interested in donating blood this Wednesday? After school donation seems to be and she's a blood draw. Yeah,
Well, you're going to have to do this yourself. I'm not selling donating blood.
Would anyone?
What that tells us about shape is the shape becomes more normal as two things occur. The first one, we have a large N. And by N in this case, I do not mean that we are taking more samples. Like we took samples of size, we took 1,000 samples. That's not what I mean. What I mean is the size of the sample. And then secondly, P gets closer to 0.5. So when we have a large N and when P gets close to 0.5, the distribution will be normal. Now, that's pretty generic. We need some specific rules, so that's what we're going to talk about. I need 10 more minutes of your time to formalize, like put in symbols, center, spread, shape, and do one example, and that will be our notes. You with me? Questions? Okay, let's go on. So of course, the first question is, when is it okay to say the distribution of p hat is approximately normal? I want to be very clear with the difference between p and p hat. P is the population proportion. P hat is the sample proportion. So when it says distribution of p hat, it is referring to a sampling distribution. It is referring to a graph where every dot is a p hat. And so we said the distribution of p hat is more normal when, we said two things, when n is large, so we're taking large samples, and when p is close to 0.5. Here's how you formally test that. N times p has to be at least 10, and n times 1 minus p has to be at least 10. When those two are true, the distribution of p hat will be approximately normal. So that is the shape. If those are not met, we don't know what the shape is, or we're not really concerned. Mean and standard deviation. If I have a whole bunch of p hats and I average them up, we already know that will be the same as the population proportion. And that's because p hat is unbiased. So if I take all of those p hats and I average them up, the center of that distribution will be the population proportion. The standard deviation, on the other hand, that is the square root of p multiplied by 1 minus p all over n. As we see, when n gets bigger, when we're taking bigger samples, our standard deviation will be smaller. Now, these are only true if our sample size is less than 10% of the population size. So this is only if we are taking a small sample relative to the population. I will show you this in a minute, but these are on the formula sheet. So you don't need to memorize them. And then in terms of interpreting the standard deviation, it is the typical deviation from p hat to p. So it's typically how far a sample proportion will be from the population proportion. This is, though, of course, in the long run with many samples. It does not mean I take a single sample and that's going to be how far the sample proportion is from the population proportion. It does not mean that. So I want to be clear, it's in the long run only when we take many samples. This is going to be the first part of your homework. It's going to say something like, describe the sampling distribution. It wants to know what is the mean, the standard deviation, the shape. That's it. Last thing is this last problem that is going to ask us to do all of them. This is the last thing in our notes for today. The superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a four-year college or university. Suppose that 80% of all middle school students in her district are planning to attend a four-year college or university, and the superintendent randomly selects 125 students. A, calculate the mean and standard deviation of the distribution of p hat and interpret the standard deviation. Okay, a few things that we are told. First off, this 80% is all middle school students. Because that's all, that is our value of p. We also are told that she selects 125 students, so that is our sample size. So in part A, what we know so far, we know the true population proportion is 0.8, and we know she's taking samples of size 125. So the mean of the sample proportion then, that's just going to be centered at the population proportion. That's from above. The standard deviation, on the other hand, is going to be the square root of that 0.8. 1 subtract 0.8 over 125. Which is 0.036. Now, those are only valid if her sample size of 125 is less than 10% of the population. It's only true if her sample size is less than 10% of the population size. So if I solve for big N, if I divide by 0.1, I'm going to get 1,250. So we need to know, is our population bigger than 1,250? Our population, in this case, is all middle school students in the district. I don't know what district this is. We know it's a big district, so we're going to assume that, yes, that's the case. So then we have to interpret the standard deviation. This is the standard deviation if we took a whole bunch of p-hats. So it's going to sound a little bit awkward, but I'm going to say in the long run, if she chose many samples of 125 students, I'm going to pause here and go back to the question. We are looking at p hat, which is the proportion of something. So in this case, we are looking at the proportion of students that plan to attend a four-year college or university. So if she chose many samples of 125 students, the sample proportion of middle school students planning to attend a four-year college or university would tend to deviate from the true proportion, the true or the population proportion, by 0.036. Again, just remember that's in the long run. That does not apply if I take a single sample. This does not tell me I took a single sample, the difference to the population proportion. It's just in the long run. Last thing we have to do is part B. Any questions before we do part B? Okay, part B. What is the probability that in a simple random sample of size 125 will give a sample proportion of at most 75%? The entire key to this question is writing probability notation correctly. So it tells us we're taking a sample, and it says sample proportion. Both of those indicate to us that we are using p hat. So we want to know what is the probability that p hat is less than or equal to 0.75. Before, what we would have done is first we would have done probably a simulation. That's like in your homework where it had the dot plot, and you find where that 0.75 is. Or we can approach this as a binomial situation. Now though, first thing, we know the center of the distribution of p hat is 0.8, and we know the standard deviation of the distribution of p hat is 0.036. So the question is, what's the shape? If it's a normal distribution, that would be lovely. So that's what we're going to check. Is the distribution normal? So we're going to calculate n times p. So my n is 125. My p is 0.8. So that gives us 100, which is definitely at least 10. So all I did was take 125 and multiply by 0.8. The other one you have to check is n times 1 minus p. So that would be 125 times 0.2, which is 100, not 125. It's just plain old 25. So these are just from above. So yeah, it looks like p hat is normal. Well, this is now just a regular normal distribution question. So we know that p hat has a normal distribution with a mean of 0.8 and a standard deviation of 0.036. Anytime it's a normal distribution, what should we do? Besides define it like I just did. Come on, what's our next step? Augie, thank you. Draw a graph. Thank you. We're almost done, I promise. Give me like 2 minutes. Draw a graph. So remember, we're going to have mean, standard deviation, 2. We have 0.8, so this is 0.836. That's something which I don't know. So what we are looking for is 0.75 and everything below it. If I'm going to do this on the calculator, what am I going to use? It's a normal distribution. Normal CDF. So we would do normal CDF. Lower bound is some big number that's negative. And then we go to 0.75, and then our mean is 0.8, and our standard deviation is 0.036. And finally, we get an answer of about 0.0824. Sorry, I took us over by like 3 minutes. 0.0824. Now, if the distribution had not been normal, we would have had to do a simulation or a binomial distribution. So if one of these is not met, you're done. You can't finish the problem. Pretty much this page is what you're going to see on your homework. One last thing I forgot to tell you. Can I keep going? This is at the beginning of your packet. This is the formula sheet, the AP formula sheet. So you're going to notice sampling distribution for proportion. We are looking at one proportion, so it gives you the mean formula. It gives you the standard deviation formula. That formula all the way on the right we haven't done yet. And it's not going to matter to us for right now. I would highly suggest you look at these formulas so that you use the right symbols, because it's going to be a pretty big deal instead of P if you put P hat, or instead of P hat if you put P. So this is on the back of the front part of the first page, rather, of the formula sheet.